welcome to my video. In this video today we are going to start again on a redesign again of the main chassis. And why is that? Well, for those of you who don't know, designing a chassis is extremely difficult. And why is that? Well, first of all, there are several preferences of how you want to design a chassis. Second of all, it has to fit all the major components, and so in my case a battery pack, and it depends on the battery supplier that you have, how big a battery you want. It depends on what type of suspension you want to run. It depends on what kind of drivetrain you run, how you want to position your steering rack, etc, etc. Now, for me, the main reasons of wanting to redesign the chassis were basically because the front of the chassis was a little bit on the short side, so I didn't have a lot of crumple zone. That was one reason. Second reason was that at the driver's shoulders the chassis was just too narrow. Another reason was that the high bar that I put in to get the shoulders underneath the chassis, basically, I really didn't like that a lot. The last chassis that I designed was basically a chassis so that I could build very cheaply, and I could build it quite easily at home. Actually, my goal was to design a sheet metal chassis and not a profile chassis. The reason for wanting to build a sheet metal chassis is because sheet metal is way more accurate these days with laser cutting and digital bending. So everything is computerized, so the failure in this chassis is just way less, and you can really engineer it with small fingers that click into each other, etc, etc. And it also, a big benefit of working with sheet metal is that it's much more easy to get high strength material. So for example, if I want to use Domex, there are no square profiles in Domex, or at least they are very difficult to get. You can get some high strength round tube, which I will be using for the roll hoop, for example. But in the old chassis that I had to use, let's call it mild steel. And for something that has to absorb a crash, mild steel is just not the way to go. But it would be cheap and it would be easy to build yourself. Then coming back to wanting to build a sheet metal chassis, I saw some dump trucks and other vehicles that nowadays they use, we call it strip kanten in Dutch, but what it means is that you take a sheet metal plate and you put several angles into it, making it into a very rigid shape, and by doing so a thin sheet metal plate will become a very rigid and strong construction on its own, and therefore you can build extremely light and still very strong. And for example, we built at my job, we build vacuum tanks. Vacuum is a very high force, and by creating a shape that has several angles into it, we can generate a very strong profile without having to add a lot of gusseting. So with that idea in mind, I went back and made a redesign of the chassis so that I could use Domex, so that I can use very thin walled plates, so 1 mil, 1.5 mil, 2 mil, 2.5 is at the thickest, basically that will help me to design a very strong and lightweight chassis that might also be much more easy and much more accurate to assemble. another thing is that now that I know my main components and I know my layout, I want to use that input to make my chassis much more strong. So for example, we have the anti-submarine bulge of the seat, and I want to use that now to be part of the chassis and really help stiffen the chassis. So it's a big sheet metal frame basically inside the chassis, and by putting that in, I have basically created a big box section inside a very tiny chassis, and that will help it tremendously with rigidity and flex and that sort of stuff. Now the same happens at the rear. I need a box section under the seat, under the back of where you're sitting basically, because the battery pack has to be there. So I am creating again a very big box section inside the chassis, which helps me to stiffen up that chassis tremendously. Another thing that I want to do is have the suspension mounts inboard of the chassis. I've started with that, and because I'm going to do that, I need to make the front half removable. So I will actually, when I make the final model of it and I go into production mode basically, so I'm gonna design all the sheet metal parts independently. Now I'm making a solid body so I can run FEM calculations on it. But if I'm starting to make this model for production, I will completely redesign the front so that I can easily take it off. So in case you have a small accident and suspension will bend the mounting points, then you can just take off the nose cone basically and put on a new nose cone. So that means it has to become a dividing point in the nose and on the chassis. That also means that the pedal box needs to transfer and some other parts like the steering column, etc. So that needs some figuring out. Yeah, so that's a part of it. Yeah, and another thing that I want to do is that in the corners I have this chamfered parts at the shoulders, and I'm stretching that so that you can lean with your shoulders against this, and that makes the seat very simple. So the seat will just be a straight plate with some bends in it. On the sides next to your buttocks and your hips and your rib cage will be fiberglass tops, just like I had in the previous design. But now the seat connects to that big box section for the anti-submarining with a hinge point, so I can just grab the seat and pull it forwards, so I have a little bit of storage under the seat. And just like in the last seat design and interior design, I will have a little bit of storage underneath your knees. So that means that you can have a small bag, your wallet, your phone, things like that you can store inside the car, which is a major benefit for, I think, for a car that is so compact. Now, the big reason behind it, as I mentioned already, was elbow room, shoulder room. At this point in time, the inside of the chassis was 52 centimeters wide, and then your shoulders could tuck underneath the chassis a little bit, but I'm well over 50 centimeters wide in my shoulders, and that's not including elbow room. So what I did now is widen the outside of the chassis to 70 centimeters or 700 mil, and that means that on the inside, I mean, the outer shell of this model is only 1 mil thick, and there is a edge inside the profile of that comes in 20 mil. So let's say all in all we have 65 centimeters inner room, um, yeah, that means that we have quite a lot more room. And the reason behind it is steering. When you're steering, you move your arms, so you want to be able to have space for that. And furthermore, I want to have the hydro e-brake, as I mentioned previously, because I want to make a drift car out of it as well. And for the steering wheel and the hydro e-brake, you just need space next to the steering wheel and around the steering column, and there was just too little space there. It was so minimal, that I really wanted to generate more space at that area. So those are several reasons why I wanted to try and do this. Again, this is a trial chassis, and I need to run some FEM calculations on it to see if we can really get it to work the way I want it. And based on that, we can continue. Another thing that I find important is that with this new chassis, I can also make the top and the bottom of the chassis chamfered in, and that will also allow me to channel the forces around the bend. When I use angle or normal profiles, I always have a 90-degree angle, and I don't want that per se. And now I have a 45-degree angle, for example, so the force flow will be much more organic around those corners. And it will transfer the forces much better into the bottom of the chassis, for example. So it will just give me much more strength out of the shape, and it will help let the forces flow much more through the chassis and the sheet metal. So I think that all in all, that this design will help me greatly with the strength of the chassis. However, the major difficulty will become assembling this chassis. What I mean by that is that everything now will click together. Everything will work as a team. And when it's one package, you think, oh, that's clever. However, for example, if I look at the sidewalls and that big anti-submarine box that I discussed earlier, that big anti-submarine box is as wide as the chassis. However, as I just mentioned, the top and the bottom of the chassis chamfer in. So I cannot just drop that big box in. That big box needs to be there, and then the side needs to be mounted against it. And also with with those lines, with those breaks in the sheet metal, you're limited to what that sheet metal afterwards can do. So, for example, if I just put a 90-degree bend in it, I can make it quite a long piece. But if I put let's say 10 bends in it, some to the inside, some to the outside, then you're becoming limited into other designs to the sheet metal. So we need to figure out where we're going to put the brake line and say, okay, this is where we weld or where we bolt or where we glue. A lot of sheet metal chassis, like loaders for example, they glue their chassis instead of welding or riveting or bolting. And the big thing with gluing is that it remains somewhat flexible, and with torsion and the chassis, etc. And also with the heat, if you put the car in the sun, then it can be a good thing to have some flexibility within the sheet metal, and because of that glue, that is possible. So it opens up a lot of doors. chassis, and basically it all just clicks together then, and with some minor welding points within that chassis, I basically have a cocoon of everything clicking together. So in theory, I wouldn't have to weld a lot. Of course, in reality, you'll weld everything still, but basically to get the basic structure to fit together, yeah, we just have to make sure that the most important parts click together and then just fixate the rest of the chassis. And I think that with the design that I'm currently working on, that is very well possible. So yeah, in the end, I'm very positive of what I'm trying to do here now. And again, we need to calculate this, and the front section will be separate and will be looking a little bit different than what it does now. But I think that the direction that we are going is a good one. And I'm taking all the good things from the previous chassis that I learned, and yeah, we're going forward to this chassis, learning even more. And yeah, it's something different. I hope that you like this type of video. I myself do like it a lot. I mean, I like to design bodies. As you can see, I designed a lot of different body styles, but it's also to explore this type of chassis build and this type of packaging. And also to show, of course, you know, if I get this thing into production, it's good to see or to show people, you know, what kind of body shells you can do with this chassis. And that's what this whole thing is about. You know, it's a skateboard in essence, which means that you have a chassis with the packaging of the components, with the wheels, the suspension, the driveline, etc. And you can choose whatever body style you want to put on top. So by designing body styles, I show that is possible, and I show very different body styles, so you can see what the options are. And but in the end, we need to have the packaging, and we need to have that chassis. So that's what I'm trying to work on right now. You'll see me working on fixating the steering wheel position, that bar that is there. That bar itself will stay there as it is. However, the angled sheet metal plate that is there right now will be completely redesigned. And the reason for that is, if I want to make a boltable front end, I need to have a front section with a big hole somewhere, so that I can put my tooling through. So the first, let's say, 30 centimeters of the main chassis, basically, I need to have that flat and smooth, so that I can put a big hole in it to get in there with tools to bolt up the nose cone to the main chassis. Yeah, so basically a lot of rambling in this video maybe, but I think it will help you understand where I'm coming from, where I'm going, and what my goal is with the design of this show.